I was debating making a video on this topic because I didn't know if I knew enough on the topic to be able to make a video, but I thought I'd throw it out there and see if anybody comments on it and what they think about it. So, one of the first things I want to talk about is this anticyclonic supercell that I saw back during the massive severe weather outbreak in May. It was in Texas, outside of Brownfield. It was like southwest of Brownfield. So I want to talk about that. So in a normal supercell, we see cyclonic rotation in the northern hemisphere. That means it's rotating counterclockwise or anti-clockwise. So that's cyclonic rotation, and that's what we in the northern hemisphere in the United States. That's what we see in our supercells. And there's a rare phenomenon known as anticyclonic supercells and anticyclonic tornadoes. So it's basically the opposite of what a cyclonic supercell is, where they're rotating counterclockwise. A anticyclonic supercell is rotating clockwise. Now in the southern hemisphere, almost it's like the complete reverse, where cyclonic supercells are rare and cyclonic tornadoes are rare. However, anticyclonic tornadoes are common. So, anyways, back to the topic. Also, quickly, I'm gonna jump in here in between while I'm editing. I forgot to point out something else I wanted to show. I'm gonna rotate this picture to show northeast motion, since this is to the east, and then we can compare it with the other one, just so you can see how the hook is matching that of what an anticyclonic or left-moving supercell should look like if it was moving to the northeast. So, here, let me rotate this picture, and you can compare it to the picture of the actual storm. So here are some pictures of the storm. Here is the Texas storm in question, the possible left-moving or anticyclonic supercell. As you can see, the hook is going towards the west. The storm's motion is to the northeast. So you can see that that hook is off to the west, while in a normal northeast moving supercell, we would expect to see it off to the east. Here is an example of that. Here's a hook echo on a supercell that is going towards the east. The storm's motion is to the northeast, the north-northeast area, and you can see that hook is arcing off to the east, while in this supercell right here, it is arcing off to the west, which is very unusual for the northern hemisphere. Here is the NROT values, and as you can see, it is measuring in the pale green to green scale, which is the anticyclonic rotation, while in the normal scale, for those of you who use GR2 Analyst, it is from blue to white, which shows how strong the cyclonic rotation is. So we're already seeing some pretty strong anticyclonic rotation as it peaks at this like solid green color, and it's not pale. So you can see there's some solid green rotation there, and that shows some strong anticyclonic rotation. Now, also, I want to use this base velocity picture. This one is from a bit earlier than this NROT picture was taken. I forgot to take more of these. I only took this one, but it is of the same storm, and it still had anticyclonic rotation at this time, based off of NROT and the hook. So, I want people who are more knowledgeable and better at reading this to tell me if this is indeed actually a anticyclonic rotation based off of the base velocity, or if this is not a anticyclonic rotation. Because I'm not very good at telling the directions. The radar station is off to the northeast, by the way, if that will help out in any way. I'm guessing it would, because you have to be able to tell which direction the wind is moving. So, we are southwest of the radar station. I don't know by how much, but I'm guessing that you could probably find which one I was using based off of that information. Also, I want to point out that this storm is possibly, if this does end up being a anticyclonic or left-moving supercell, then this is definitely the most defined version of a anticyclonic or left-moving supercell we have seen in the United States, because I have found very few pictures other than that one I showed earlier of a left-moving supercell. And if this one does actually show that it is a left-moving or anticyclonic supercell, then I think that this would be a good example to show to people who are wondering what they should look for, what like a textbook version in the northern hemisphere looks like. This is definitely a very good example of that, if that turns out to be the case. Please leave all of your feedback in the comments, and please also uh, correct anything I said wrong, or uh, if give extra information. Ask questions, because I'm guessing that either I or other people in the comments who are more knowledgeable about this can probably answer them, um, and possibly clarify anything that I said if I said it unclearly. So, anyways, thank you for watching, and I will see you guys in the next video.